All right. Hello, guys. This is Aaron with Wiltry Pool Service here. So I wanted to go over some stains. So staining in your pool, right? You've got some kind of a discoloration or stain in your pool. I wanted to talk to you guys a little bit about what might be causing that. Um, there's not there's not a whole lot of things that it can be, right? I mean, there's only several things that it could be, and then if you reduce that down further, there's only a few things it's likely to be, right? So I'm going to go through it using a mind map here. So what we're going to do is we're going to go ahead and open the stains tab, right? So you got a general stain in your pool. It's a discoloration. You don't know what it is, but you're trying to get rid of it, right? There's two broad classifications of stains, right? You have organic stains and then you have metal stains, okay? Those are the only two possibilities. Like literally it can't be anything other than these two, okay? Like you're not going to see something that's not an organic stain or a metal stain, right? We're going to start with an organic. In case you don't know what that term means, that just means anything. Organic means it was living or it did live at one time and now it's dead, okay? Whereas a metal stain is just anything that has to do with a metal. It's got like some kind of a metal in it, right? So organic stains. Um, there's two. There's two broad things, classifications when you're talking about organic stains, right? It could either be tannins in the water, and tannins are like so it can either be tannins or it could be anthocyanins. Okay, both of those things are what we call a polyphenol, right? A polyphenol it's like a plant dye, so it's like some part of the plant that's colored that can stain. So if you think about tannins, right? Tannins are they're like brown or black dyes inside of leaves, or they're also in acorns. I think they're also in pine needles, like dead pine needles. But basically, they're like a dark um, they're dark polyphenol. They're a compound inside of the plant that has the potential to stain. A lot of times, what you're going to see is let me see if I can show you a picture here. If this is going to pull up, hopefully, hopefully you can see kind of like what this is. I know this is literally the largest picture I could find. On the right here, you don't see a lot of stains. On the left here, these are tannin organic stains, right? You can see imprints of leaves. A bunch of leaves were sitting here in this pool in the corner here. This is probably opened up like in the fall. Like they literally probably just opened this up at the end of the season and then they see this, right? Anytime you have a big pile of leaves at the bottom of your pool that are sitting for a long time, you're going to have tannic acid stains, right? Anytime you have a tree, an oak tree, sitting over your pool, dropping a bunch of acorns in, and they're literally just sitting on the bottom, you're going to have tannic acid stains. Okay, it's literally just a matter of time, right? So that's kind of what the tannic acid stains look like. Anthocyanins are from berries. Anthocyanin is another polyphenol. It's a dye inside of the berry. Like if you spill wine on like a white shirt, those are anthocyanins. They're like purple bluish stains. They're very rare. I tried to look for a picture. I couldn't find one because they're pretty rare. Like you're usually not going to see these. And if you have a bunch of berries falling in your pool sitting on the bottom, yeah, that's what's causing it. It's going to be like a bluish purple. You're going to see berries down there too. That's an anthocyanin. So those are your two broad classifications. How do you get them out of your pool, or how do you even know if it's an organic stain? Because some organic stains, as you're going to see, they're going to look similar to metal stains, right? So how do you get them out of your water? The best way is the way you remove organic stains is you're going to use chlorine, right? Some kind of an oxidizer, any of the halogens, right? So chlorine, bromine would do it. I mean, those are the two that you're going to use. You take a chlorine puck, you sit it on the stain. If the stain goes away, you know that it's an organic stain, pretty much. So you remove it with chlorine. Chlorine oxidizes the stain, so literally is just going to like remove it. So you use chlorine. Okay, So that's organic stains. I'm going to leave that open. Okay. Then your second classification of stain that you can have, and I'd say these are probably more common from what I see like out in the field. I'd say metal stains are a little bit more common than organic stains. You have a lot more of them. Okay. So metal stains, you have iron stains, you have copper stains, calcium stains. You can have manganese stains, cobalt stains. Okay, so you got 1, 2, 3. Yeah, you got 5. Okay, so you could be 5. Now, realistically, I ordered these in the order of you're the most likely to be seen, or this is most likely to least likely. Okay, so for instance, I see iron stains all the time, like literally all the time in pools. It's very common. I've never seen a cobalt stain in my pool service career. They're very rare. Apparently, it exists, but I'm going to show you some pictures of these so you can kind of see, right? So, iron stain, it's just Fe in the periodic table. All of these are in the middle of the periodic table, right? These are all metal, caused by metal ions, right? Reacting with usually oxygen to form a metal oxide, which is what stains it, right? So the iron stain kind of looks like this. Hopefully this is big enough. You're gonna almost always, if you have a fiberglass pool, it's not a matter of if you're gonna get a copper stain, it's a matter of when. Okay, and you will almost always see it on the steps first. And even if you don't have a fiberglass pool, almost everyone has fiberglass steps, right? And this pool, you can see over here, there's a liner pool, vinyl pool, but his steps are fiberglass. They just make the fiberglass steps, and the fiberglass is where you're going to see it first. Okay, so if you have a fiberglass pool, it is a matter of when you get this, right? So iron stains because they're going to be rust colored, right? Which makes sense, right? Because it forms ferric oxide, right? Which is basically rust. It's like an underwater rust. It's going to be like an orangish brown against the white. That's how you're going to see it. This again is extremely common. Okay, that's an iron stain. Okay, a copper stain, it's going to look a little bit different. Let me show you a picture of that. Copper stain is going to be black. This is extremely solid. Again, guys, I apologize. I tried to make this big. I don't think I can. Let me see if I can zoom in. Can I? I guess I can. A little bit. Hopefully you can see that. Like it's on the bottom, and it's going to be like a widespread black stain. Okay, it's going to be like a diffuse black stain on the bottom. It's not going to be like it's not really going to be like in patches, right? Sometimes if you see it like growing in patches, it's something else entirely. It's a black algicide, which looks more like a fungus. You'll be able to tell that. This is more of kind of like a gray black. It's kind of all over the place on the bottom. This is a copper stain. Okay. Now, go ahead and zoom out there. Copper stains are a little bit less rare. So I see copper stains a decent amount too. They're not as common as iron stains, but they're there. Okay, then calcium stain. There's actually two kinds of calcium stain. Now calcium. So we said iron is brown, copper's black, calcium's white. Anytime you see something white, you're dealing with calcium. Okay, which is again just another type of metal. It's I think it's an alkali metal over on the left side of the periodic table. If you see kind of white powdery residue, especially like on tiles or above your pool, or like in this case, this was like a water fountain or waterfall, and as the water was falling down, the calcium was left behind, right? Because calcium's in the water, but it stays behind. So anytime you see something like this where it's like white powder or above the water line, especially on the tiles, but it can, I think it could be underwater too, but you're usually going to see it above water. This is calcium carbonate, okay, which is different than calcium silicate. So calcium carbonate is more common than calcium silicate. Calcium silicate is rare. You're probably not going to see this very often. Um, I wrote down a description. It's sharp, crystallized, and sandy particles attached to tiles. Okay. Calcium silicate, it was hard to find a picture. This is kind of what it looks like. You're gonna, if it looks like a crystal, white rock crystal structure that kind of decomposes into sand, you're dealing with calcium silicate, which is, again, it's more rare and it's harder to get rid of than calcium carbonate. Okay. But generally speaking, right, if it's white, it's going to be calcium. Okay. Manganese is the next one. A manganese stain is, now we're getting into some very rare stains that you're probably not going to see very often. If you do have a manganese stain, it's going to make your pool look purple like this. Okay. This is like an extreme case. I don't know what the heck this guy did for his pool to get it to look like this. Like, it looks like Barney, the dinosaur. It looks like Barney jumped in. I had a pool party in there with his friends. So this is like manganese. I've actually never seen this before in real life. So apparently they exist out in the wild. But if you have any kind of a purple stain, don't rule out your manganese. Cobalt is the fifth one. I've actually never seen cobalt. Apparently it exists online, although it seems like other people haven't really uploaded many pictures of it. From what I understand, it's black. It might be like copper. So there's that, right? So what causes, generally speaking, what causes iron? Like, where does the metal come from to get into the pool, right? A lot of times the metal can come from, if you're putting in a metal algicide. A lot of algicides have copper in them because they're very effective at killing algae. They also have the side effect of introducing copper into your water, or a copper ionizer. A lot of pools have copper ionizers because, again, the metal ions are very effective at destroying algae cells because they remove electrons from the algae, causing them to be destroyed. So iron can also be from fertilizer, right? Metals in general, but especially iron can be from fertilizing your soil when you're cutting your grass, right? And your grass clippings and your dirt get up in the air, they get in the pool. Maybe you put some fertilizer down. Now you got iron in your pool. It can literally just become airborne from like your neighbor's lawn too, right? And these things are just generally present in the soil too. Calcium, the same way. Not really sure how. Oh, well, calcium is introduced into your pool because it's a natural constituent of concrete. A lot of times in a new pool, I just had a customer recently. He has calcium silicate in his pool. And the way it got, it's a brand new pool, he just had it installed. That when the builders built it, they use calcium silicate as an additive for concrete, apparently. And if they don't build it correctly or they don't seal it off properly, the calcium from the concrete can literally leach into the water, and then it forms these crystals or this scale on the pool surfaces, right? So it literally comes in from the concrete itself. The water wants a certain amount of calcium, so it will literally pull it out of the concrete to get it because it really wants it. It's like really desperate for calcium, right? So it'll do that. So that's kind of how you get calcium in. I don't really know how you get manganese in your pool or cobalt. So, but I guess there's ways, right? That's how you get it into your pool, right? So how do you get it out? How do you remove that? We said for organic stains, you have to use chlorine to get them off. And that's also how you test them. Literally how you test these stains is you have to apply the treatment and see if it works. That's literally what you do. So the metal stain removers, there's three primary ways you can get it out, right? You can get it out with acid, okay? um, you can use an acid. The reason that you need two things to form a metal stain, especially for metal stain, you need the metals to be present and you need the pH to be high. If the metals are present but the pH is low, you're not going to see metal stains, right? If the pH is high but there's no metals, you're also not going to see metal stains. They have to exist together, okay? And that goes for iron stains, copper, calcium, manganese, and cobalt. Okay, so the high pH will cause the stain to appear. So what you do is you add acid. Okay, now you can add. There's several different kinds of acids you can add. You can add ascorbic acid, which is one of my absolute favorites. I don't know why it works so well, but it really works. Um, Between the two, so there's ascorbic acid. Technically, citric acid is stronger, but I have not had good success with citric acid. I've had very good success with ascorbic acid. It's like magic, especially if we're talking about an iron stain or even a copper stain, especially these top two, ascorbic acid. Literally just go on Amazon, buy ascorbic acid in a big bag. It's the same thing as vitamin C. Ascorbic acid is vitamin C. So go to bodybuilding websites, just get a big bag of vitamin C. It's apparently like a performance enhancer. Get that, pour it in your pool. And if you have an iron stain or a copper stain, and especially like fiberglass, literally the next day you're going to go out and you're going to be amazed. It's going to be, you just call me in the morning, try it. Citric acid, muriatic acid is also extremely effective. Be careful with muriatic acid. These are going up in strength. So ascorbic acid is weak. Citric acid is a little bit weak too. Muriatic acid is very strong. So it's effective. I had an iron stain about this bad the other day with one of my clients. It was literally about this bad. It was actually worse than this. I poured muriatic acid directly over it and I watched chunks of it coming off. Like not like chunks of fiberglass, but like sheets of oxidized iron were literally coming off of it. It was actually really cool to see. So if you pour in muriatic acid, just, I mean, it's not like, I mean, you got to be careful with it, but just make sure you don't get it on you. Make sure you hold your breath when you're pouring in. Pour it in like directly above the water. Don't pour it in high up because then it's going to splash. So add acid to your pool is very effective to getting rid of them. It doesn't actually get rid of the metal. What it does is it makes the metal soluble in water. So they're still in the pool. So you'd have to get it out somehow. So what a chelator does, a pool chelator, basically it's like a molecule that will wrap around the metal ion and it forms something called a coordination complex. It acts as the ligand with the metal ion forming the coordination center. So basically what that means is that it binds at several points around the metal ion and it basically like latches onto it. It forms like a ring circle and it prevents the metal ion from dissociating. So it basically like imprisons it. And what it does is it like rips it off the wall and it imprisons it. So it like hugs it and prevents it from reacting to anything else. So again, it's not going to actually get it out of the water, but it holds it in suspension. Okay. The primary difference between a chelator and a sequestrant is a pool sequestrant is very similar to a chelator. It also forms a coordination complex with the metal ion, but a sequestrant can grab onto like 5 metal ions, whereas a pool chelator can only grab onto one at a time. So of the two, a sequestrant is like 5 times more effective. It forms like a star. It kind of looks like a star if you could see it, whereas this forms like a ring with the metal ion kind of like completing the ring. It's like a chain. So of the two, I would go with a pool sequestrant if you're going to use one. And also the other difference between these two is a pool chelator will it'll grab onto the metal ion, but it's too small because it only grabs onto one. It's too small to be filtered out by your filter, whether you're using a pretty much any kind of filter, like a DE filter, cartridge, or sand, it's going to be too small. It's going to go right through, go back into your pool. So you're not really solving the problem. You're just kind of like temporarily putting a band-aid on it. Pool sequestrant, because it's larger and it forms like larger coordination complexes, it's going to be able to be filtered out by your filter. So it's going to grab onto like 5 metal ions, and then it's going to go to your filter and get trapped by the sand, and then you can backwash it. Or if you have a DE filter, you could also backwash it out of your pool. So you're basically removing metal. So of the two, I'd go with sequestrant. Now, let me just make sure I'm getting all the notes here. Yeah. Um, the only downside of a pool sequestrant is that a lot of times some of the most effective pool sequestrants are phosphates. Um, they work really well, but remember, phosphate becomes food for algae. It happens to be what algae eats for food. So if your phosphates are very high in your water, a lot of times that's how phosphates get high in the water. People have recurring problems with algae, and they don't know what they're doing wrong because they're literally doing exactly what they've always done, and your pool is still green all the time. It might be because your phosphates are high, and it might be because you used a metal sequestrant to get metals out like last year, and then you thought that was the end of your problems, but now you're having algae issues. So just be careful with that. Some of the most effective sequestrant. So if you're going with a sequestrant, you might want to go with a phosphate free version. Um, just something to think about. So yeah, that's it in a nutshell, guys. So we talked about the organic stains, metal stains, and different types of those and how to get rid of them. So hopefully that was helpful for you guys, and I'll see you in the next one.